Hi everyone, my name is Leon van Berlo. I'm the Technical Director of buildingSMART International. I'm so sorry I can't join you at this wonderful conference. Unfortunately, the travel from the Netherlands to Brazil was a little bit too much, which I regret. I was at BIM Forum Brazil last May and I had a wonderful time. I'm really looking forward to my next visit in Brazil again. So I was asked to do a presentation about the openBIM workflows, basically explaining what all of these abbreviations mean. And I would really like to do that by starting at the basics, starting from the beginning. So usually things start with a good idea, a great idea often. From that you want to try to get that idea that is in your head into the heads of someone else. So at that point it already starts to get tangled up in translations and difference of interpretation. So eventually you come up with some kind of a drawing or a sketch, and over time we improved and the drawings got better and we got standards in drawings. I think it's always underappreciated how many engineers know that they have to tilt their head to the left to actually read what is on a drawing. Those standards are really important for the productivity in our industry. And these drawings got better when we got digital. We made a lot of digital drawings, so you didn't have to scratch the inked pens anymore, which I still remember vividly, but you can just do it much more effective and efficient. Then eventually we got even smarter with digital. Now we are not drawing lines anymore with the computer, but we are modeling objects. We're modeling relationships, geometry, often in 3D, and other properties like geometry that are maybe a little bit more considered data. So now that we have this data, this smart data, this object-oriented data, we can do smarter things like automate tasks and eventually even do advanced simulations. And these simulations is what it's all about. This is the end goal, this consuming of data to do construction simulations, cost simulations, scheduling, maybe life cycle analysis, whatever. It doesn't really matter what you do with the data, but that is the end goal. We consume the data and we do something with it. To be able to do that, you have to input these systems with a certain state. So when we take a road or a bridge, someone has to model the design or the actual situation of the bridge and the road to be able to put it into a simulation and get results. Often, to do this in an effective way, you also need to know the requirements for the data. So these simulation tools need data as input, but they also have certain requirements for the information to be able to run the simulation effectively. When you do this, there's a lot of tools out there that can do this full flow. Just come up with the information requirements, model the data, and run a simulation. All in one software tool. Same tool, you don't need anything else. It runs very effectively the data, and that's it. But this is a locked system. It only runs within that system. You can't communicate with anyone else. You cannot collaborate, you can't participate, and if you want to do changes, you're stuck to that system. So the ideal situation is that you can have different choices for each of these steps. You can have different choices what software tool you want to use, of which software tools, if it's multiple, you want to use to define your information requirements. You want to have the ability to choose between multiple tools or use multiple tools in the same project by different partners to create the actual information. And there's probably also multiple tools who run different kinds of simulations eventually, because not one software tool runs all of the simulations you need during operation or during the design. So, but eventually also you want all of these software tools to be able to work together in this seemingly integrated workflow. This is where openBIM comes in, the ability to fine-tune and to tweak the tools in a workflow that you decide. Why is openBIM important? Because you want to have the data available to anyone. That doesn't mean that you need to publish it out there and anyone can use your data. You still choose with who you share your data. But at the moment you share your data with someone, that person has the ability to actually use the data. They're not being forced to buy a license of a certain software tool. They're not being forced to use your software tool. They're not being forced to pay a fee before they can open your data. Because your data is structured in a way that is openly defined, means that everyone has the ability to do an interpretation of your data. Also important is that everyone has the same interpretation of your data. So everyone understands what a beam is if you share your bridge. Everyone needs to understand the definition of a load-bearing parts in a road. Everyone needs to understand where you place materials and what is the allowed material list, for example. So also it is important that these definitions are not decided by one software vendor that then maybe has the ability to tweak the definition and the standard in a way that favors their software tool. This is also why openBIM is important, because it needs to be a standard that is based on international consensus that is constructed in a collaborative way. And finally, for end users, the most important one, in my opinion, end users have the ability to control their own destiny. They can choose what software tools they want to use in any kind of project. They can work internationally. They can define their own workflows. If they don't like it in a certain project, they can switch it around and use other tools, because that is what is better at that point. This controlling of your own digital destiny, having a durable, long life cycle of data flows in projects and companies, that is possible thanks to openBIM. So why is this important? That depends on your perspective. So from a government perspective, it's important that there's a number of different software tools that are competing with each other. This will stimulate fair competition and also innovation in the industry. You need open standards to be able to create such an ecosystem where any kind of software tool can enter the market in a level playing field. From the software vendors' perspective themselves, it's important to support openBIM to allow users of your software tool to collaborate with others. And it also allows you to compete on features. If you invent a feature that is really cool and works very effective, there's a lot of users, for a lot of users it's easier to switch to your software because you provide a better product and not because you have some kind of a lock-in. And for end users, you can participate in any project with the software tool of your choice, no matter what country, no matter what client, project type. Because you adhere to these open definitions, you can hit the ground running and participate in any kind of project with the tools you choose that work best for you. So who makes this all possible? Who drives all this? This is buildingSMART International. It's a non-profit, globally operating organization. You can read all about it at buildingSMART.org. It's driven and supported by members. Different membership levels pay different kinds of fees to drive and accelerate the strategic agenda. There's local chapters, and also in Brazil, recently a local chapter has been formed together with BIM Forum Brazil. I think at the conference that you are now, there's also local representatives of buildingSMART Brazil and BIM Forum Brazil that can help you understand buildingSMART and openBIM better. So that was the introduction, the first 10 minutes. What is it? Why is it important? So let's dive a little bit deeper on the details of it and the specifics. And this is where all of these abbreviations come in. So as we saw earlier, the simplest process is create information requirements, create information based on these requirements, and then feed that information to a simulation that can consume the actual data. In reality, it's a little bit more complex, obviously. because you also want to check if your information is actually created according to the requirements before you run the simulation. And the step in between is also that you want to have some machine interpretable, computer interpretable information requirement, so you can do this check automatically. So when we look at these steps in the buildingSMART, in an openBIM world, in the buildingSMART environment, these are the abbreviations we use. So we define computer interpretable requirements using an IDS file. IDS stands for Information Delivery Specification. The information that we share is done using the IFC standards, the industry foundation classes. Some people call it information for construction. So this is this information, this data is being shared using IFC, usually in files, sometimes direct APIs. So what also comes in handy if you want to define your requirements is that you have a library to search. And if you create this data, this IFC file, might be coming handy that you have some kind of a validation tool to check if the data is according to the standard. So buildingSMART, besides the standard, also has these services. The BSDD is the buildingSMART Data Dictionary. It's basically an online library where you can search existing terms and standards and definitions. Again, globally operating. The validation service is a service where you can upload your IFC file and you get input how well your IFC is structured and how good it is adhering to the IFC ISO standard. Other standards are the BIM collaboration format, BCF, that you can use to exchange your results, your checks, and the OpenCDE APIs to easily share the results and the data. So let's just run this process. Looking at the time, I think we still have some time left to do this. So let's start with creating information requirements and let's search the BSDD. So for example, let's search for a stair. When you go to the BSDD and you search for stair, you immediately see there's a couple of different results here. On the left you see the different domains, the different dictionaries. There's Dutch ones, there's Danish ones, there's Uniclass, but on top there's IFC stair. So the first result when we search for stair is actually an IFC object. So let's dive into what that is. When we look at IFC, the industry foundation classes, we see that this is really an open standard. The open definition is available online. You can Google it. You can see who changed it. It's very transparent who contributed to this standard and this definition and this page. It's very collaborative. You can help improve and suggestions. It's versioned. You can really trace back who changed what, why, when. And it's all openly available at buildingSMART.org. So when we go to IFC stair, you can see that a stair has a certain definition, it has relations, it inherits some of the properties from other objects. It has a certain way of how to connect geometry to it. It is really huge. It's a very stable definition that is over 25 years old now. So this is very extensive, but it's just one stair. And all of this information is openly, publicly available. And again, this is important. The license of IFC basically says you can do whatever you want as long as you don't make changes. So it's very open and transparent. You can do whatever you want, but you can't make changes because we want to have it as a standard and have it predictable and reliable. So we found an IFC stair. It's very extensive, but if we search something specifically for Brazil, there's no matches. So how big is IFC and is it big enough? So I can already tell you it is pretty big. It has thousands of objects, about 12,000 properties. It is massive. So the question is, how big should it be? And this is where it becomes a little bit technical, so I'll try to skip over this relatively quickly. So we're halfway the presentation. I don't want to lose you here. So when we look at IFC, actually this stair is a type of product, but a further type of stair can be a specific Danish one. And even further detailed, that can be a company-specific stairway in Denmark. So there's a certain specialization hierarchy in this setup. So for IFC, it has the same. There's a core, there's a kernel, there's shared elements, there's different modules, there's different domains like road, rail, infrastructure, architecture, obviously, MEP, construction engineering. So the different modules are part of IFC, but they share the same core. They share the same way of linking geometry. They share the same way of linking properties. And then on top of that, you can further enrich that with additional classification references, additional user-defined properties, regional requirements or agreements, etc. So this lower part is what we call IFC. It is the common denominator that we can globally agree on. So at a global level, this is what we can agree on. And then further specifically, like the Danish stairway, or maybe even a Brazil-specific classification system, that is something where that can really work together with IFC. So you can have a Danish-specific stairway that is a further specialization of an IFC stair. All of this, both the IFC objects and properties and the additional extensions or amendments, as we call them, is published in our buildingSMART data dictionary. So that's where we started. Remember, we searched for a stair and we got these results. So you get IFC as the first results because that's the strongest standard. But we also see this Danish stair. It's called LXSB, which is a code that everyone in Denmark knows. This is a Danish definition of a flight of stairs. It has links to IFC definitions and properties, but it is the Danish standard. So for those of you who are interested in the buildingSMART data dictionary, there's different standards, different dictionaries that are published. All of them can have their own license. So this is published under the MIT license. They have an ownership, they have a version, they have a link to IFC, and they have a unique URI as an identifier. It's all according to several different ISO standards. So if you're interested in that, I encourage you to look at bsdd.buildingsmart.org where there's more information. So going back to our process, we know that we can use the BSDD to search for terms, and we can put them in Excel or in Word or whatever kind of human readable format. And we also know that there's this relationship with IFC information that we are requiring. But there's this missing step of requiring information according to a computer interpretable way. And according to a computer interpretable way means that you cannot ask for LOD whatever, because nobody really knows what that means. You can't say, give me IFC. You can't say, just give me everything you have, or I need stairs. It really needs to be more specific. So a good example would be, there should be at least one stair, and every stair must have a property number of riser, and the value of that property needs to be higher than 1. So this is where information delivery specification IDS comes in, because this is where we have this computer interpretable format that translates these requirements from human readable text to computer interpretable text. And this is also where you can make this relationship to the buildingSMART data dictionary. So in this case, what I mean by a stair is that Danish stair that you can find in at this link in the buildingSMART data dictionary. This is where you can find the license under which you can use this data. This is where you can find who owns it, what the definition is, what the relationship is to other standards, etc., etc. So this trifecta of the buildingSMART data dictionary, the IDS file, and the IFC data is something that is very important for these openBIM workflows. This is how it all connects. You have the service that publishes the different standards. You have IES as a standard to define requirements, and you have IFC as a standard to exchange the actual information of your project. So now the IFC file is created. I'm sure many of you have already seen the export to IFC function in your tools. So for the sake of times, I'll skip through that. Maybe what you don't know is that you can use the buildingSMART validation service. It's available at validate.buildingsmart.org. You can upload your file and you're getting results. Not if your file is valid according to the requirements, not if your file is valid for your project, but if your file is structured according to the ISO standard. So does your file have the relationships and the correct properties, or are properties linked that are actually not agreed on by the standard? So this validation service is something relatively new. It's in beta, as you can see, but it is something that we are investing in to improve a lot more in the future. So next step then is to check IFC against IDS. You can also check against your project requirements, against design requirements. We all know the software tools where you can set up rules and check if these rules are met. Is the fire extinguisher in every room? Is there a flight path for? Is it short enough to the nearest fire exit? All of these kind of rules. There's a lot of software tools out there that can do that. All can read IFC. You can choose the tool that you prefer best. That's the beauty of IFC and openBIM. And then you have the results of that check. And it's always the question, how are you going to communicate those results? So again, there's examples here. People put up get the telephone or an email. The door is too small, the second one from the left on the third floor, the red one. And this is just asking for problems, obviously. So in the buildingSMART world, this is where the BIM collaboration format comes in. This is where you can pinpoint exactly this door is the door I mean. This is the camera angle on how to look at that door. This is the priority I want to give it. This is the person that I assign this to. These are the history, comments, etc. All of this is machine interpretable in an XML format to be exchanged between different partners. So then we're almost there. We have the BIM collaboration format to exchange the issues that we find from a check. And then the last step is to actually share the results to share the IFC file, or maybe even the issues from the BCF, to others. And this is where the openCDE API standard comes in. So this is a relatively new interface standard, and we don't have fancy pictures of this yet, but the easiest way to explain is an example, a use case where you want to download a file from a CDE. So the steps you're taking is you open a browser, you log in, you find documents in your CDE, you download the files, you save them to a folder, and then you open them in Solibri or in any kind of those tools that you want to use to consume your data. So the ambition of the openCDE project at this time of the Documents API module is to reduce these number of steps. So to only log in and open the files directly from the data that you use to consume your data. So this is quite interesting. If you Google or find a video on YouTube, you will see how this works between Solibri and Aconex. There's more and more software vendors that are supporting this. It's really a growing standard that is underappreciated and deserves more attention. So I'm happy to dedicate another half an hour presentation on this the next time I hope to be in Brazil. So this is where we kind of can come to this relatively complete picture that we can paint. The full openBIM workflow. You define requirements using information delivery specification, computer interpretable files. Then you create information using an IFC standard, exchange that usually in files, sometimes also directly through APIs. You can exchange issues or topics to discuss using the BIM collaboration format, and then the topics or the IFC data can very easily and effectively, efficiently be shared through one of the openCDE modules, which is the umbrella term we use for the API standards from buildingSMART. So together, this is what we call the openBIM workflow. It really stands on the foundation of these separate standards. As you noticed with the buildingSMART data dictionary and the validation service, we also try to make it easier to use these standards by providing additional services. These are not standards, but services that you can use. You also see a logo UCM that hasn't been mentioned yet in this presentation. This is the use case marketplace or the use case management tool. So this is where you can find existing use cases from other users. So if you need to execute a certain use case and you're not sure about the best exchange requirements for that use case, you can search on ucm.buildingsmart.org, where you can find multiple best practices on several topics. So this is also where, again, we can differentiate between different regions where sometimes use cases are executed differently. And then finally, we also have a certification program. The buildingSMART software certification program checks if software is implementing the standards correctly. So currently we have an IFC certification program, software certification, but we're also extending that to IDS, BCF, and OpenCDE. And the professional certification program, I think, is extremely important. This is where we educate and train professionals. There's different levels of this one. Again, this is also another half-an-hour presentation on the entry level, the foundation level, the practitioner modules, the BIM manager modules. You can get trained, you can get certified by buildingSMART, by your local chapter, or by buildingSMART International. I know it's very successful in Brazil. There's already quite some training providers and quite some professionals already certified. But I also know that the level of openBIM usage in Brazil is quite high already. So I congratulate you with that. So that's it for me. This is the full overview with a maximum time limit of half an hour. I was very happy to be able to share this with you. If there's any questions, please feel free to reach out to me. Just try to send me an email. I'm also on WhatsApp, which I think is quite popular in Brazil as well. So feel free to contact me. Happy to try to help you. All right, that's it. Sorry again that I can't join you. Hopefully I'll see you next time. Feel free to reach out for any questions. Looking forward to help. Thank you.